Well, so let us start with Boolean algebra rules and laws. Okay. So in algebra, in general algebra, as we have in general algebra, we have addition, subtraction, multiplication, etc. Right? Similarly, in Boolean algebra also we have addition. In Boolean algebra also we have addition, subtraction, and some laws we have, just like commutative law, associative law, distributive law. Okay, we'll see. Let us see how to write all these laws, basic rules. Okay. So as you can see in the screen, the addition, we know while doing the binary addition, we have done this. 0 plus 0 is nothing but 0. Okay. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is there. For the addition, we have written it as 0, 1. But here in Boolean algebra rule, we write it as 1 only. Okay, 1 plus 1 is equal to 1. While doing the addition, actual addition, we have written it as 0, 1. But remember, it is not 0, 1 here. While doing the Boolean algebra addition, take it as 1 only. Okay, that means we are applying these values to different logical gates or different logical circuits. Okay, at that time, this 1 plus 1 will be equal to 1. To say this is not addition what we are doing, actually this is the OR function we are doing. Okay, we say 1 or 1 is equal to 1. That we'll see later. Now just remember, as per the addition rule, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 1 only, not 0, 1. Okay, sorry, not 1, 0, as we have done it for the addition. 0 was the sum, 1 was the carry. Now forget this. So 1 plus 1 is equal to 1 only. Similarly, multiplication. For the multiplication, okay, we have 0.0, which is equal to 0. Definitely 0.1 is equal to 0 only. 1.0 is also 0 only, and 1.1 will be equal to 1. This is same as the general multiplication, right? Remember this much. Now, this addition, we call it as the OR function, and the multiplication is called as the AND function. We'll see later what is this OR function exactly, what is this OR function, and what is this AND function. Okay, or you remember, for the time being, you remember that addition is nothing but the OR function, multiplication is the AND function. Okay. Next, some of the laws. Okay, some of the laws in Boolean algebra. First law is nothing but the cumulative law. Cumulative law. So this law says that A plus B, remember that this A and B are the variables. A plus B can be written as B plus A. Okay, A plus B, plus is nothing but the OR function. A ORed with B can be written as B plus A. One example I'll tell you, 0 plus 1. 0 is the value assigned for variable A, and 1 is the value assigned for variable B. This is also equal to 1 plus 0, right? Very simple, isn't it? 1 plus 0, which is also equal to 0 plus 1. Both will yield the same result, right? Similarly, we can write A dot B is also equal to B dot A. Isn't it? A multiplied by with B, or exactly to say this is A ANDed with B is equal to B ANDed with A, or B multiplied with A. right? 1 into or 0 into 1 is also equal to 1 into 0, 1 dot 0, isn't it? So both are same. From both multiplication, we get the same output, isn't it? So this law is called as the cumulative law. The other one is associative law. Associative law. So this law says that A plus B plus C, we are putting the bracket to B plus C, is also equal to A plus B, we are changing the bracket, plus C, okay? A plus B plus C, this is also equal to A plus B plus C, okay? Let us take one value for A, B, C. 0 plus 1 plus 1 is equal to, we have to write it as 0 plus 1 plus 1, right? So let us add this. 1 plus 1 is 1 plus 1, not the general decimal addition, okay? 1 plus 1 is the Boolean addition, which will be equal to 1 only, plus 0. 0 plus 1 is equal to 1. Just before this, we have written, right, the addition rules. So as per the addition, what it says, 0 plus 0 is equal to 0, 0 plus 1 is equal to 1, 1 plus 0 is equal to 1, and 1 plus 1 is also 1, okay? According to that, if you write 1 plus 1 is equal to 1, okay? It's not equal to 2, remember, it's not the decimal addition, it is the binary addition. So 1 plus 1 is equal to 1 added with 0. So 0 plus 1, from this table if you see, 0 plus 1 is equal to 1 again. Go to the other side, okay? In the other side, 0 plus 1 is, from here, 0 plus 1 is equal to 1 plus 1. So 1 plus 1 is 1. Therefore, LHS is equal to RHS. Left hand side is equal to right hand side. We can say the associative law is, this expression is correct, okay? So A plus bracket B plus C is equal to bracket A plus B plus C. This is associative law. This can be written similarly for the multiplication also. Associative law for multiplication, how to write? A into B C is also equal to AB into C, okay? For the addition, we have written it as A plus B plus C is equal to A plus B plus C, okay? For the multiplication, A into BC is equal to AB into C. Let us take some value for this. 1 into 1 dot C, 1 dot 0, okay, any value. We are considering A is equal to 1, B is equal to 1, and C is equal to 0. So substitute these values here. In the left hand side, let us see 1 into 0. What we have written from the rule, from the multiplication rule, 0 into 0 is 0. 0 into 1 is also 0. 1 into 0 is also 0. 1 into 1 is 1. Okay. So 1 into 0, first the bracket value you have to find out. So the product inside the bracket you have to find out. Later on, multiply it with the value which is outside. Okay. So here, this is 1 into 0 is 0. So it is multiplied with 1. Again, this value will be 0 from this table. Okay. In the RHS, what we have, A is 1, B is also 1. Put the bracket here. C is 0, right? First, you simplify this. 1 into 1 is 1, okay, into 0, which is also equal to 0. So LHS is equal to RHS. So this associative law is verified, isn't it? This is how we can apply the associative law to any of the Boolean variables, just like our mathematics. But here, one thing you have to do, you have to remember is, we are dealing with the digital bits, binary bits. Okay. Next law is distributive law. Distributive law. So in this distributive law, how do we write? A into B plus C is equal to multiply A with B, okay, multiply A with the C. Distribute this. So AB plus AC. So according to distributive law, A into B plus C is equal to AB plus AC. All of you know, familiar with this distributive law, associative law, and cumulative law, right? So this is how we can simplify any of the Boolean expression. This is one Boolean expression, isn't it? We are having three variables, A, B, and C, and it is written in using Boolean functions. Okay, this is about the distributive law. So three laws we have seen. One is the associative law, cumulative law, and distributive law. Next, some basic rules which are called as the postulates. Okay, they are called as the postulates. Postulates. Okay. So you can see some of the postulates in the table here. I'll tell you. One by one we'll take up. First one, A plus 0 is equal to A. Let us see what is this. A plus 0 is equal to A. A plus 0 is equal to A. Say A is a variable. This A is a variable. It can have either 0 or 1 value, right? A can have 0 or 1. Now put that value here. When A is equal to 0, it is 0 plus 0, which is equal to, from the addition rule, 0 plus 0 is equal to 0. That means this has become equal to A. So to verify this with A is equal to 1, apply here 1. Okay, substitute A is equal to 1 plus 0, which is also equal to, maybe 1 plus 0, that is equal to, from the addition rule, it is equal to 1. Therefore, the value, the result or the output is depending upon the value of A, not this 0 value. It is not depending upon the 0 value. It is depending upon this A value, right? As the A value changes, the output is also changing, and it is becoming equal to the A value. So A plus 0 is equal to A. That is the very first rule. You have to remember this. Okay, while simplifying any of the Boolean equations, we need all these postulates or the rules. So A plus 0 is equal to A. Second rule says A plus 1 is equal to 1. Okay, A plus 1, whatever may be the value of A, the output will be always equal to 1. This is true, right? Consider A is equal to 0, 0 plus 1, which is equal to 1. Or if A is equal to 1, then also 1 plus 1 is also equal to 1 only, right? So whatever may be the value of A, the output is remaining equal to 1. It is remaining 1 only, isn't it? So A plus 1 is equal to 1. This is the second rule. Third rule says that A dot 0, A multiplied with 0 is always equal to 0. Okay, A multiplied with 0 is always equal to 0. Again, apply 0 or 1 for A. If A is equal to 0, 0 dot 0 is equal to 0. If A is equal to 1, 1 dot 0 is also 0. Therefore, the output is always 0 only. Hence, A dot 0 is equal to 0. Next, fourth rule, basic rule says that A dot 1 is equal to A. A dot 1 is equal to A. So if A is equal to 1, if A is equal to 1, then 1 dot 1. 1 dot 1 is equal to 1 only, right? If A is equal to 0, I'll write here. If A is equal to 0, 0 dot 1, that's equal to 0 only. So the output is now depending upon A value. Therefore, A dot 1 is equal to A. This is how we can we can verify that rules by applying some values for the variables. Okay. Next rule, let us consider the next rule. What it is the fifth rule, A plus A is equal to A. Okay. All the rules you have to verify by applying 0 or 1 to the variables. So this A plus A is equal to A. According to the rule, it says that A plus A is equal to A. Now let us apply 0 to A. Okay, A plus A. Therefore, 0 plus 0. A value we have taken it as 0. So 0 plus 0, which is equal to 0 only. Right. If A is equal to 1, it is 1 plus 1, which is also equal to 1. Therefore, this value is definitely equal to A value. Right. So A plus A is equal to A. Next rule says that A complement plus A is equal to 1. Okay, A complement plus A is equal to 1. What is this A complement? Now, let us consider A is equal to 0. At that time, A complement will be equal to 1, right? So, A complement, we have taken A is equal to 0. Therefore, A complement is 1. 1 plus 0, which is equal to 1 only. You have to remember the addition rules. Okay, it should be clear for you. So at that time only you can write all these rules. Okay, if A is equal to 1, A is equal to 1, complement of A will be 0. So for that also, for that possible combination also, possibility also we'll see, A complement is 0, A is 1, again 0 plus 1 is 1. Therefore, A complement plus A is always equal to 1. Okay. Next, seventh one says that A dot A is equal to A only. Okay, A dot A dot A is equal to A. Again, consider the two values for A. When A is equal to 0, 0 dot 0, which is equal to 0. When A is equal to 1, 1 dot 1, which is also equal to, this is 0, which is equal to A, right? This is 1, which is equal to A again. Because we have taken A as 1. Therefore, A dot A is equal to 1. Next rule, I'll write here, 8th rule says that A complement dot A, which is equal to 0, always 0. Remember, A complement plus A is equal to 1. A complement dot A is equal to 0. Consider this, A is equal to 0, A complement is equal to 1. So 1 dot 0, which is equal to 0 only, right? When A is equal to 1, when A is equal to 1, A complement will be 0. This is the second case. So 0 dot 1 is also equal to 0. Therefore, always A complement A is equal to 0. Remember this. Okay. Next. There is some problem in this ninth one. Ninth one is A double complement. Okay. Here there is a small mistake here. You may correct in your notes. A double complement. This is double complement. A double complement is equal to A. Okay. So A double complement, what it means? A complemented once. This is complemented again. Okay. That we call it as double complement. Complemented twice. Now let us take one value for A. A is equal to 0. Okay, at that time A complement will be 1, opposite of this, right? 0 will be equal to 1 when we complement it. Now complement it once again. A complement is complemented again. Okay. So what we have to do? We have to complement this 1. 1 is complemented, which is equal to 0. Definitely that is equal to the original A only, right? So it will be equal to A. Therefore, A double complement is equal to A. A double complement is equal to A. Remember this, A double complement is always equal to A. Okay, 10th one will take up. So A plus AB. A plus AB, this is equal to, the rule says that, or the postulate says that it is equal to A. Let us see how this is happening. Okay, now A is common. This is one term in the expression. A is the one term. AB is the second term, right? This is the first term and AB is the second term in our expression. Now A is common in both the expressions, right? All of you are familiar with this, isn't it? By taking A outside from both of the terms, A is common. So we can take out A outside. We can take out A. What remains in the first term? Only 1, right? 1 remains in the first term. In the second term, B remains, right? In the second term, B remains. This is nothing but the distributive law. If you multiply it again with 1 plus B, you'll get A plus AB only. Now, A into 1 plus B. A into 1 plus B. See, B is one more variable, which is just like A only. It is other variable. A is the one more variable. Now from this postulate A plus 1, see here in the table where the cursor is moving, A plus 1 is equal to 1. Similarly, see from the postulate we have written as A plus 1 is equal to A. Okay. Similarly, instead of A, I can write B also or C also, anything you can write. Totally, it is a variable. So if you add 1 to any of the variable, the value remains or the output is equal to the variable only. Okay. So B plus 1 is equal to B only. A plus 1 is equal to 1. A plus 1 is equal to 1. B plus 1 is equal to 1. C plus 1 is also equal to 1. Whatever may be the variable value, the output is always equal to 1 only. Therefore, whatever may be the variable value, it is even if it is Z plus 1, then also the output is always equal to 1 only. Therefore, if you consider this 1 plus B, A into 1 plus B, that is equal to 1, right? A into 1. Now A into 1 from the other postulate, A into 1 here in the fourth postulate what we have seen, A dot 1, which is always equal to A. So A dot 1 is A. Therefore we can say A plus AB is equal to A. A plus AB is always equal to A. Okay, these are some of the postulates which you have to remember in Boolean algebra. Okay, so these postulates are given with the circuits that you can go through once. This is about different basic rules what we are using in Boolean algebra.